Recording has started. Okay, so let's start. Do you have any question? Sorry. Okay, so let's start. Good evening, everyone. My name is Chandan Kumar Gupta. I am a Prime Minister Research Fellow in Department of Mathematics, IIT Patna. I am your NPTEL-PMRF Teaching Assistant for the course Probability and Statistics. This course is offered by Professor Somesh Kumar. He is a faculty in IIT Kharagpur. This is a 12-week course, and we are in the 6th week of live session. Okay, so let's start what we will cover in this week. Okay, so up to week 5, like we have discussed about algebra of sets, definition of probability, and then random variables, kinds of random variables, and then univariate distribution, Bayes theorem, continuous and discrete univariate distributions, probability distributions. Okay, in week 6, we will discuss about bivariate, or in generalize, we can say multivariate distribution. Okay, so we are going to discuss joint distribution. Okay, so we are going to discuss joint distribution here. So like in the previous weeks, we have one random variable and we say that's it's nothing but height, or suppose x2 is another random variable, weight. Similarly, xn is another random variable, body temperature, etc. Okay, so these are different kinds of univariate if we are treating one at a time. Now, in today's class, we will discuss two or more than two random variables together. So, suppose we take x1 and x2. Okay, so we have considered two random variable together. So this is called jointly distributed random variable. Okay, so these kind of distribution, joint distribution random variable, we can also take x, y, x, y, z, u, v, etc. These are the notations for random variables. Okay, so here like we consider together, simultaneously consider, for example, let's say height and weight. Okay, so we can consider two different random variable together in a distribution function, and that distribution is joint distribution function. Okay, or when we consider 3, 4, 5, and n, then multivariate distribution. Okay, so there are different kinds of joint distribution, like joint gamma, beta, etc. Okay, but in today's class or in this course, we will discuss only about the bivariate normal distribution. Okay, so bivariate normal distribution. Okay, so we will discuss about bivariate normal, like here EVN. In short, we will show bivariate normal. Okay, so there are many properties, different kind of skewness, kurtosis, and all the things for this distribution. But first, let's start about the notation. So let xy or x1, x2, whichever you like. Okay, let xy follows the bivariate normal distribution with the parameters. Like in normal, like if you remember, if x follows normal, it's mu and sigma square. So there are two parameters. Okay. Now in bivariate normal, we have five parameters actually. So like it's mu x, mu y, sigma x square, sigma y square, and there is one more quantity rho. Okay. For x, there is mu x and sigma x square, y, mu y and sigma y square. And there is a rho that is correlation coefficients that defines the linear relationship between the variable x and y itself. Okay. So we have five parameter distribution now. Okay. So obviously, uh, it's PDF for the bivariate normal distribution. The same notation we are going to use. Okay, fxy and within parentheses small x, small y. This is the standard notation for bivariate normal distribution, for bivariate distribution actually, not normal, for any kind of. So the PDF is like 1 upon it's 2 pi sigma x sigma y under root of 1 minus rho square. Okay, this is the constant term. Now we have exponential term. Okay, in exponential term, the first one is like minus of 1 upon 2, 1 minus rho square. Okay, and then we have like curly bracket, and within this x minus mu x upon sigma x whole square. The same x minus mu upon sigma whole square, the similar, minus twice of rho x minus mu x upon sigma x, y minus mu y upon sigma y. Okay, and then plus. It seems like a plus b whole, a minus b whole square formula kind of thing. Okay, and the last one is like y minus mu y upon sigma y whole square, the square bracket and the curly bracket. So this is the probability density function for the bivariate normal distribution. Okay, same x belongs to like the real number k, mu x, mu y also belongs to the real number, sigma x, sigma y is greater than 0, and rho belongs to minus 1 to plus 1, including both. So that means, so this is the PDF for the bivariate normal distribution. Here mu x and sigma x square is the mean and variance for the random variable x. Actually, there is different kind of properties for the bivariate normal distribution that we will discuss some of them. Okay, so this is the PDF. Now we have different kind of bivariate distribution, but from those bivariate distribution, when we construct the marginal distribution, it is not from the same class. But in case of normal distribution or method is bivariate normal, the marginal distribution of x as well as marginal distribution of y comes from the same family of distribution, that is the normal one. Okay, so that means what? So this implies like when we are going to construct or evaluate the fx of x, that is the marginal distribution of random variable x. Okay, this is the same x, xy. Okay, so this is what? So let me denote by this. This is integral fxy, fy, dy, and here the range of y. So this is the general formula for the marginal distribution of x. Now, for this normal case, let me write directly, the x follows the normal distribution only itself with mean mu x and variance sigma x square. Okay, so this is the property. The marginal distribution of a bivariate normal distribution is again a normal distribution with the corresponding parameter mu x and sigma x square. And similarly, for y is again normal mu y sigma y square. Okay, so this is one of the case. Also, suppose we have like conditional kind of thing. So f x given y, these are the like general notation. Okay, so this is the conditional distribution of x given y equal to small y. Okay, so this is the conditional distribution of x given y equal to small y, and this is what, as you people remember actually already, we write here like probability of a given b. This is the same formula, the conditional one. Probability of a intersection b on probability of b. So in the same way, we can like write x given y is nothing but the joint xy divided by the given condition. So that means fy of. So this is the case when we are going to discuss about conditional distribution for normal or bivariate normal. Same, okay, the same has been observed for y given x. But here again, there is one twist, like this x given y equal to y. Actually, this again follows the normal distribution with different sets of parameter values. Like this one is like mu1 or mu x plus rho times of sigma x y minus mu y upon sigma y. Okay, so this is the mean value. This is the mean value for the conditional x given y. Normal with mean of mu x plus rho times of sigma x y minus mu y upon sigma y, and the variability is like since mu x square and 1 minus rho square time. Okay, so this is the conditional distribution of x given y when x and y are jointly distributed as bivariate normal distribution. And yes, you can obviously write the same for the y given x equal to x, which is again the normal distribution. It's mu y plus rho sigma y, just replacing or exchanging x and y together. X minus mu x upon sigma x. It's sigma y square 1 minus rho square time. So that means what? If xy is jointly distributed as bivariate normal, then the marginal of x, the marginal of y, the conditional of x given y, and the conditional of y given x all follows the normal distribution with different sets of parameter values. Okay, so this is the property only for normal distribution. Okay, so now the next is, yes, that was already like we can understand that things, but let me write again here. Like if xy is bivariate normal with mu x, mu y, sigma x square, sigma y square, row. Then in that scenario, the expected value of x is obviously it's mu x. The expected value of y is mu y. Here, as we have already discussed in normal distribution, that the parameter value itself, the first and second order moment, that is the mean and variance. Okay, but not in all the case. Like suppose if x follows binomial NP, then the expectation of x is not equal to NP. This is wrong. Variance of x is not equal to p. This is wrong. But in case of normal distribution, the parameter itself, the mean and variance. Okay. So mu x, mu y. Similarly, variance of x is like sigma x square. Variance of y, sigma y square. And yes, there is a correlation coefficients actually. Correlation coefficients between the variable x and y. So the correlation defines there is a linear association. The degree, it measures the degree of linear association between the random variable x and y. Okay, so this is here nothing but rho, and as we know, rho always lie within -1 to +1, including both. Okay, so this is the case. Now, okay, also we know that like a correlation coefficient, the formula for the correlation coefficient is actually covariance between the random variable x and y and divided by sigma x, sigma y. So that means the standard deviation of the x and y random variable. Okay, so this is one of the formula. Also, there is one more formula. What is the formula for covariance? Covariance between the random variable x and y is it's like expected value of xy, okay, minus expectation of x into expectation of y. Okay, so this is the case. Also, we know that when the correlation, let me write here as rho. So correlation or the value of rho may comes out to be -1, 0, or +1, and any value within this. So when it is -1, that is perfectly negatively correlated. +1, okay, let me write here. Okay, like rho equal to 0. So, okay, we can't see actually anything. Let me write here first -1 +1, perfectly positively correlated. Rho equal to -1. So it's perfectly negatively correlation. And if rho equal to 0, so we say that there is no correlation, but in not that sense. That means there is no linear association between the variable. I'm talking about only the linear association. No linear association. Okay, so there is one note actually. If rho equal to, sorry, if two random variables, say xy, are independent, then the correlation between them is 0. Okay. When the two random variable are independent, then the correlation is 0. But the converse is not true. And the converse is not true. Okay. So that means when we have like the correlation comes out to be 0, that doesn't mean the variables are independent. Okay. So this is one of the note that we may use in numericals. Okay. So we have correlation here. Now covariance, correlation. Obviously, from here you can derive many formula. The correlation rho. So we can also have one formula. So since let me write the notation only. The correlation is covariance between the random variable x, y, sigma x, sigma y. Obviously, this is nothing but the covariance between the random variable x, y is rho times of sigma x, sigma y. This is also one of the formula that you may use when we are given such kind of information in the numericals. Okay. Now let's come to the moment generating function for the bivariate normal distribution. So again, xy follows bivariate normal with mean mu x, mu y, sigma x square, sigma y square, and rho. Okay. Then the moment generating function xy comes out to be like what? Expected value of e to the power fx plus ty e to the power ty tx. In univariate, in bivariate, we have two. So s and t is there. And for bivariate normal, it comes out to be like the expected value of mu xs plus mu yt plus half of sigma x square s square plus half of sigma y square t square plus rho times of sigma x, sigma y, s and t. Okay. So this is the moment generating function for bivariate normal distribution. Okay. Also, there is one more property. Actually, there are lots of property of normal distribution or bivariate normal distribution. So suppose z. Z is another random variable which is nothing but the linear combination of two normal variate ax plus dy. So as we know that the linearity property of normal distribution. So here again the same things. So z follows normal distribution with a times of x, that is mu x, plus b times of mu y. This is the mean value, and the variance value is like a square sigma x square plus b square sigma y square plus twice of ab sigma x sigma y rho times. Okay, so twice a b, which is the coefficients for mu x and mu y respectively, then sigma x sigma y, the standard deviation of the random variable x and y respectively, and mu time rho times. Okay, which is correlation coefficients. So these are some of the properties of bivariate normal distribution. So from normal to normal, we are already within the normal, just here and there. Okay. So these are some of the topics that has been discussed in week 6 lecture. So if anyone have any doubt, he or she may ask. Otherwise, we will solve some numericals based on these topics. Okay, so let's start to solve some numericals. So the first numerical is like, suppose that xy is a bivariate discrete random variable, is a bivariate discrete random variable such that the point one comma 2 occurs with probability 1/4. Occurs with probability 1/4. The point 1,3 with probability 1/2. The point 2,3 and 3,1 with probability 1/8 each. Okay. Calculate probability y equals to given x equal 1. So this is the question. Okay. We are given a discrete bivariate discrete random variable such that the probability at 1, 2 is 1/4. 1, 2 is 1/4. 1, 3 is 1/2. And these two have a probability 1/8. Okay. We need to find the conditional probability that y equal to 2 given x equal to 1. So every time, always remember when you are going to solve the joint discrete kind of question, always make or prepare a table. Okay. So let me write here. Okay. So we have two random variables. So let's x and this is y. Okay. So x is like 1, 2, and 3 because you can see here the first value is x. So 1, 2, and 3. So there are three possible values of x. Again, for y as well, it's either second observation, 2, 3, and 1. So this means what? This means like 1, 2, 3. Okay. And we are given some property, sorry, some probability value, some prior information. That means, so that means what? 1, 2 have probability 1/4. So x equal to 1, y equal to 2 have probability 1/4. Then 1, 2 have 1/4, 1, 3 have 1/2. So 1 and 3 have 1/2, and 2, 3 and 3, 1. So 2, 3 and 3, 1 have probability 1/8, and 3, 1 have probability 1/8. And the rest of the values are nothing but 0 actually, because that those are not given. So this means what? Means 0. These are the information that are given in our question. And we need to find the probability. That means the conditional probability. So first thing, always remember when this kind of table you are like successfully constructed, then you can find the marginal of x as well as marginal of y probability for those variables as well. So it's like, so this is actually marginal of x, okay, for x is equal to 1. And this is what? This is the sum for x is equal to 1 at y equal to 1, 2, and 3 all. So it's 1 by 4 plus 1 by 2 comes out to be 3 by 4. Okay. So marginal, that probability that x equal to 1 has probability 3 by 4. That means 75% of the probability lie within at x is equal to 1 only. So now here 0 plus 1 by 8 comes out to be probability that x is equal to 2 is 1 by 8. And probability that x is equal to 3 comes out to be 1 by 8 again. And similarly for y, the probability that y equal to small y. So this is probability plus y equal to 1 comes out to be 1 by 8. Probability that y equal to 2 comes out to be like 1 by 4. And probability that y equal to 3 comes out to 1 by 8, as this comes out to be 5 by 8. Now the first step is to make sure that this joint distribution is a valid joint distribution. So this can be verified by summing either the marginal probability of x or y. And both from both the sides, it comes out to be 1. And yes, you can see 5, 1, 6 to 8. So 8 by 8 comes out to be 1. And here 3 by 4, 1 by 8, 1 by 8 comes out to be 1 again. So this means this is the proper or valid joint discrete distribution. Okay. Now this is the case. We have joint and as well as we have marginal of x and y both. Now our question is like we need to find the probability that conditional y given x. So we have already know since probability of a given b comes out to be what? Probability of a intersection b, that means the joint probability divided by probability of b. So we can say that probability of y given to given x equal to 1. So probability at y equal to 2 given x equal to 1 comes out to be probability of y equal to 2 x equal to 1, that is the joint probability. Here I have written y equal to 2 given x is equal to 1, but let me write, actually this is also correct. There is nothing wrong in this, but since we follow the ordering, so x equal to 1, y equal to 2, and it is divided by probability that the given condition, that is x equal to 1. Now we have joint PDF, x equal to 1, y equal to 2. So you can see x is equal to 1, y equal to 2. X equal to 1, y equal to 2 has the probability 1 by 4. Simple. At x is equal to 1, y equal to 2, we have the joint probability 1 by 4, which comes out to be 1 by 4. Now at x equal to 1, so only x equal to 1. So that means now we need marginal probability at x equal to 1, which is our 3 by 4. So it's 3 by 4. Obviously 1 by 4, 3 by 4 comes out to be 1 by 4 into 4 by 3 comes out to be y equal to 2 given x equal to 1 by 3. So this is our answer. Okay. Is it okay up to this point? Is it okay? Anyone? Like we can even construct more numericals on this. Okay, thank you. Like we can construct more problems for the same question. Okay. Here we have like calculated y equal to 2 given x equal to 1. What if uh, we calculate some other terms like probability that y is less than or equal to 2? Okay. So y is less than or equal to 2 implies what? Since y have value 1, 2, and 3. So less than or equal to 2, that means y equal to 1 plus probability of y equal to 2. It comes out to be y equal to 1 is 1 by 8. Y equal to 2 is 1 by 4. So it's 1 by 8 plus 1 by 4 comes out to be 3 by 8. You can construct any kind of numerical, like expected value of y. Like, what if I say what is the expected value of y? So as you know, since this is a discrete distribution, so y from 1 to 3, because y have value 1, 2, or 3, y probability that y equal to y, or what? 1 into probability as 1 by 8 plus 2 into probability, I think it's 1 by 4, okay, and then plus 3 into probability of it's 5 by 8 actually there, 5 by 8. Now you can calculate, it's 1 by 8, it's like 2 by 4 plus it's 15 by 8, comes out to be 8, 1 plus 4 plus not 8, it 15. So it comes out to be 20 by 8, which is 2.5. This is our expected value. That means expected value of y is 2.5. Okay. In the same manner, even one more thing. Even if you have recall the topics that we have covered in the previous lecture, these are not actually in the list, but since y have value what? Y have 1, 2, and 3. Okay. And the mean value comes out to be here. Okay. So most of the data in the second half. Simple. And this can also be verified with the help of, like, can we understand? With the help of this value, if you can see, it's 1 by 1 by and 5 by 8. So it's 5 by 8 means more than half of the probability lie at the last point. So that means obviously this kind of, actually this is not a kind of curve, this is just a point, but most of the probability lie in the second half. This implies it is nothing but negatively skewed distribution. So if you have like concepts of the previous things, previous definitions, then you may analyze the data. Okay, you may analyze the data by yourself only. You don't need to like many things. In the same way, like what if I say probability x is greater than 1? Or let me formulate one more question. Probability that x plus y is greater than 3. Now it's somewhat laborious or lengthy. Okay, now we have x plus y is greater than 3. And we have x equal to 1, 2, and 3. And y also have 1, 2, and 3. Okay, so obviously we have probability that x equal to 1, then y is not equal to 1 because x plus y comes out to be 2. So this is not the case. If we put y equal to 2, again, we have a strict increasing kind of relation. X plus y is greater than 3. So this means what? Here, neither 1 nor 2. Here it comes out to be 3. So probability that x plus y is greater than 3 equals probability that x equal to 1, y equal to 3 plus probability x equal to 2, because x equal to 1 have all three combinations. 1 and 2 is not there, only 3 is there. Now probability that x equal to 2 and y equal to 1 is not there. Y equal to 2, yes, because 2 plus 2 comes out to be 4, which is greater than 3. Now the probability that x equal to 3, sorry, x equal to 2 and y equal to 3 is also there, because 2 plus 3 comes out to be 5, which is greater than 3 again. Now the next case is x equal to 3, because 2 have all the three cases, out of which 2 is there. Okay. X equal to 3 and then y equal to 1 plus probability that x equal to 3, y equal to 2 plus probability x equal to 3, y equal to 3. So by these like kind of algorithm or whatever like steps, you can find the joint probability under these kind of things, like x plus y is greater than 3, x plus y is lie within 1, 2, 3 only, then there is again you can write the joint distribution in that manner. Okay, so let me write x equal to 1, y equal to 3. So x equal to 1, y equal to 3 has probability 1 by 3 actually. Okay, plus x equal to 2, y equal to 2 has probability 0, plus x equal to 2y equal to 3 is 1 by 8 plus 3, 1. 3, 1 has probability 1 by 8 plus 3, 2 has probability 0 plus 3, 3 has probability 0. Okay. So yes, now it's 24. It's 8 plus 3 plus 3 comes out to be like 14 upon 24 or 7 upon 12. Okay. Just in the same manner, you can solve different kinds of questions. Okay. You may create your own question for a single question and then solve whatever you want to find out. Is it okay up to this point? If anyone have any question regarding the joint discrete distribution, then he or she may ask. Okay. I have one more question, the same kind of question, that is the joint discrete distribution. Suppose x and y are two discrete random variables with the joint PMF with the joint probability mass function. When we are discussing about discrete case, then we say mass function instead of density function. Usually, I and many of the many people say density function in general, but if it is discrete, then probability mass function is the right word. Okay, so it is the joint PMF given as in the following table. So again, I need to find like construct a table. X equal to 0, x equal to 1, x equal to 2, y equal to 0, y equal to 1, y equal to 2, and y equal to 3. So this is the case, this is the case. Okay. So let me write it's A, it's A, it's 2A, it's 3A, then 3A, A and 2A, and then 5A, it's 3A, it's 2A, 4A. Okay. Now you can construct a variety of questions from the same data. Okay. So this means what? This is probability X. I'm writing X, that is a, let me write this. X equal to X, probability that Y equal to Y. Okay, that is a marginal. So here like 1, 2, 4, and 7A, 3, 4, 5, 7A, 5, 3, 8, 10, it's 14A. In the same way, it's 9A, it's 5A, it's 5A, it's 9A. Okay, comes out to be 28A. So this is the case. This is the, if this is a valid PMF, then the first thing is what? Then the first thing is obviously it's 28. Okay. Since summation x, y, probability that x equal to x, y equal to y comes out to be 1. Here it is again like 28A comes out to be 1. From here, A comes out to be 1 upon 28. The value of A is 28. Sorry, 1 by 28. Okay. Now the question says find the variance of X. We need to find the variance of X. So if you people may recall the formula for the variance of X, it is like the expected value of x square minus expectation of x to the whole square. Okay. Here these two x square both are like what? Non-central moment. Please remember, these are not central moment. Expectation of x and expectation of x square as non-central moment, and variance of x is a central moment, second order, that is. Okay. So yes. So let's first calculate the expectation of x. The simple question. Okay. Just go step by step. You will find the variance of. So yes, it's x into probability that x equal to x. And the value of x is what? The value of x comes out to be 0, 1, and 2. So let me write here 0, 1, and 2. So it's 0 into probability that x is equal to 0 what? The probability that x is equal to 0 is 7a. Okay. So it's 7a plus 1 into again 7a, if you can see, again 7a and 1 into 7a and 2 into 14. 1 into 7a plus 2 into 14. So expectation of x comes out to be 0 plus 7a plus 28a. Expectation of x is 35a, or since the value of a is 1 by 28, so it's not 38, it's 35 upon 28. So this is the variance. Okay, sorry, this is not the question actually. So this is the expectation of x. Now we need to calculate the expectation of x square as well, which is again summation x from 0 to 2, x square probability that x is equal to x. This is the notation. Now it's 0 square into something comes out to be 0. So let me write 0 directly. Plus 1 square into 7a plus 2 square into 14a. Comes out to be like what? 7, 4 into 14. So it's 0 plus 7a plus 4 into 14 comes out to be like 56a. Okay. So expectation of x square is what? Like it's 63a. Now the variance of x, which is expectation of x square minus expectation of x to the whole square. It's 63a minus 35a. Okay, let me write here 35a whole square. So yes, obviously, if you can write, you may find it's 28 into 28. If 1 by a square is like what? 1 by 28. So it's 63 into 28 minus it's 35 into 35. Okay. Now it's nothing, just simple calculation. Okay. And once you are solving these things, like it comes out to be 1764 minus 1225. And 28 into 28 comes out to be 28 square. You may solve, it comes out to be 539 upon 28 square. And once you solve, you will find 0.6875. Okay. Also, you can also see one thing. Here the mean value comes out to be this, which is actually 1.4. Okay. So here in this particular case, in this particular numericals, you may find the expectation of x is greater than variance of x. Okay. Like if x is binomial, you may remember.
Sir, that is 1.25, earlier one.
Okay. Yes, thank you.
Yeah, because 7
1.25.
is common.
Yes.
7. 5 by 4.
Yes,
5
it's
by
5 by 4.
4
That is 1.25. Okay.
Exactly.
And yes, here my actual aim is to here, like we need to see always what any kind of statistical characteristics or property or moments or anything that we calculate. We need to observe all those things all the time. Okay. So like here in this particular question, mean value is greater. Okay. Okay. The same thing happened for the binomial as well, actually. The expectation of x is NP, the variance of x is NPQ. So obviously, in binomial case, the expected value of x greater than variance of x. Okay, so the same case follows. So that means what? If you may like want to say anything about the skewness of this particular distribution that is given in this question, this is okay. You may say this. You may say this that this distribution is positively skewed, or you may say that if we have like two halves, the first half and the second half, the first half have more probability as compared to the second half. Okay, that we have already discussed in skewness part. Okay, so again here we can say this. Here since not the curve can like for the discrete case there is no curve actually, there is points, but most of the probability lie within the first half. More than 50%, that means obviously. Okay, so these can be visualized, and this is what the basic for the data analysis and data visualization, whatever you want to say. Okay, so this is the case. You may also calculate many other statistical characteristics for the same case, for the same distribution. Okay, so up to this point, if anyone have any doubt, he or she may ask, or let's move to the joint continuous kind of question. Okay. Now we have a question like let x and y be two continuous random variables with the joint PDF. Now it's PDF because it is continuous random variable, so it's PDF. With the joint PDF is given like this: fxy small x small y is 6xy when x lie within 0 to 1 and y lie within 0 to root x and 0 otherwise. Actually, this is the proper or standard format to write the like the distribution actually. Okay. For the support, these are called the support actually. Okay. These the range, whatever you say, these are called the support for the distribution. So under this condition, the probability value comes out to be 6xy. Otherwise, it is nothing but 0 only. Okay. So this is the exactly and the right standard form to write the PDF. Okay. Now we need to calculate the expected value. Now calculate expected value of like y given x. We need to calculate the conditional expectation. Okay. So yes, we will start from first step. Okay. The first thing is what is the formula? Obviously, the formula will be like the expectation of y given x. This is what. Okay. Since we are dealing with the continuous, it is integral y given x, that is y given a particular point. Okay. So x is kind of a like a constant kind of, not exactly. That means and we have known value of x. So it's y, then the conditional distribution, because it is a conditional expectation, then it is f of y given x, and write x equal to x, y given x equal to x, and dy. Okay. So this is the formula. And yes, we have the range for y as well here. Okay. So this is the formula for conditional y, sorry, the conditional of expectation of y given x. Okay. So let's start. Now we need the conditional distribution as well. Here to proceed, we need conditional distribution. So yes, f of y given x. Again, the same formula. It's fxy, the joint, divided by the conditional one, that is given x. So it's marginal of x. Now this is the formula. Now next step is to find the marginal of x because we are given the conditional only. Sorry, the joint only. So from joint to first marginal and then from marginal to conditional and then from conditional to using this formula, we can calculate the expected value of y given x. Okay, it's simple. Now there is only calculation. Okay, so let's start. The first is x, that is the marginal of x. And this is what? Since it is marginal of x, then the integral run over y, the range of y or the support of y is what? It's 0 to root x. From 0 to root x, and it is 6xy, and it's dy. Now what? 6, since dy is the variable, x is treated as constant. So 6x can be taken out from the integral sign. Integral, it's 0 to root x, it's y dy. And yes, everyone know the integration for this. It's y square by 2. It's 0 to root x. Now it's 3x because 2 and 6 can be cancelled out to become 3x. And y square, it's root x square. Okay? Root x square minus 0 square. So obviously it's 3x square. So the marginal of x is like 3x square. And the range of x is what? The range of x comes from here only, 0 to 1. Every time, if you have any kind of doubt, like you are performing the right calculation or not, just make sure, just integrate this value over the range 0 to 1. If it comes out to be 1, then it is a valid or correct. If not, then it is incorrect. Okay, so every time just verify by yourself. This is the case. Verify by yourself whether it is right or not. Okay, so our marginal is 3x square. Now what? Now the conditional. The conditional of what? Y given x. Conditional of y given x is fxy, the joint, the marginal. The joint is what? 6xy, and the marginal is 3x square. Okay. So obviously it comes out to be like 2y on x. And here this is the case. Root y, sorry, it's root y. Root x, not root y. Y from 0 to root x. So this is our conditional distribution of y given x. Now the last step is to expected value of y given x, which is integral. It's y given x is what, like f of y given x. Y given x is equal to x dy y, and this is 0 to root x y into 2y dy, 2y by x and dy. Okay, since it's dy, 1 by x can be taken out and 2 is also like act as a constant. So 2 by x as a constant, it's 0 to root x, it's y square dy. Now what? It's 2 by x, y cube by 3, 0 to root x, it's 2 by x into it's x to the power 3 by 2 actually by 3. So yes, after solving, you may find it's like 2 by 3 x to the power 1 by 2. So this is the general value of expected value of y given x is equal to x. Okay, suppose if we say like expected value of y at x is equal to 1. For example, I say at x is equal to 1, then it comes out to be like 2 by 3 into 1 to the power 1 by 2. Obviously, it's nothing but it's x equal to 1 comes out to be 2 by 3. Okay, so this is the case. Okay, what if I say what is the value of x is equal to like 0.25? So this is what 2 by 3. It's 0.25 to the power, it's 1 by 2. Obviously, it's 2 by 3 and it's like 0.5. Okay, so it's 1 by 3. Comes out to be like what? Expected value of y when x is equal to 0.25. It comes out to be 1 by 3. Okay, so when we are given a conditional value that x is equal to this at x equal to this, then you can put the value after solving the general value. Okay, if not, since in this question we need to calculate y given x is equal to x, so it's 2 by 3 x to the power 1 by 2. If I have taken like consider a value x is equal to 1, x equal to half, and x equal to any value within the range, within the support 0 to 1 is given here, the support is 0 to 1. So we have to consider the all those value only that lie within 0 to 1, including both. Yes, it comes out to be these kind of numerical values. Okay, so this is like how to solve the joint distribution continuous nature. Okay, any doubt up to this point? Okay, then we will solve next question. It's a kind of lengthy question. The question says, consider following joint density functions. Consider following joint density functions. It's f1, x1, y1, and f2, x2, y2. That is f1, x1, y1 is one joint distribution and x2, y2 is another. Corresponding to the random variables, obviously the same value in capital 1, the x1, y1 and x2, y2 respectively, or else. Now the PDF is given as like this. It's f1 of x1, y1 comes out to be like 6 e to the power minus 2x plus 3, 2x1 plus 3y1. Okay, we are given x1, y1 is greater than 0 and 0 otherwise. Okay, this is given. And the second distribution also is given, like f2 x2 y2 is 6x2 y2, and x2 lies within 0 to 1, and again y2 lies between 0 to root x2 and 0 otherwise. Okay, we are given this condition, like x1 y1 f x1 y1 is one joint distribution, f2 x2 y2 is another joint distribution with these joint distribution function. Now we have actually kind of statements. So I'm not going to write the statement, I'm just write the main part. So which one is correct? Like the A is, we are given x1 y1 is independent, but x2 y2 is not. Okay, you can understand x1 y1 is independent, but x2 y2 is not independent. Let me write. The same, the second one is like x1 y1 not independent, but x2 y2 independent. Okay, the third one is like both independent, and obviously the last one is like both not independent. Okay, so we are given the joint distribution, two joint distribution. We need to check whether out of those joint random variables, which pair has independent and which has not, or both has either independent or not. May also be possible. So let's solve this. Can anyone tell me how to check the, because all the four option as says about the independence or not independent. So how two random variable are said to be independent or not? Can anyone tell me? See, if x and y are independent random variables, then the joint distribution of xy is equal to the product of their marginal distribution. If and only if, this is if and only if condition. Okay, so if this anyone like if x and y are independent, then the joint is equal to the product of their marginal. If the product of the marginal distribution comes out to be a joint distribution, then that means those random variables are independent in nature. Okay, so it goes in both way. Independent, then marginal equal to product of, sorry, the joint is equal to product of their marginals, and if the product of marginal comes out to be equal to the joint, then that means those variables are independent in nature. Okay, so using this concept, let's start with f1, that is x1 y1, which is what? Which is 6 e to the power minus of 2x1 plus 3y1. Okay, yes, 0 otherwise. So that means what? 6 e to the power minus 2x1 plus 3y1 comes out to be like 2 into 3 e to the power minus 2x1 into e to the power minus 3y1. Okay, these are already discussed actually. Very simple question. Anyone can guess even. This is nothing but a exponential, the product of two exponential. So we can write like this, 2 e to the power minus 2x1, and the second one is 3 e to the power minus 3y1. Since lambda e to the power minus lambda x, it means x follows exponential lambda. So that means here what? X1 follows exponential 2, and y1 follows exponential 3. Okay. And yes, this is nothing but the PDF. Okay, this is nothing but the PDF. So fx1 of x1 comes out to be what? 2 e to the power minus 2x1. And fy1 of y1 comes out to be like 3 e to the power minus 3y1. And here also you may see f of xy, it's x1 y1. x1 y1 comes out to be f x1 of x1 into f of y1 of y1. So what? That means what? This implies x1 and y1 are independent random variables. Is it okay up to this point? It's simple, no? We can write the product, sorry, the joint distribution as a product of two different PDFs. So that means what? That means it is if and only if condition. So x1, y1 is nothing but the independent random variable. In the same manner, in a similar manner, you can calculate for now f2 of x2, y2, which is 6x2, y2, or x is equal to this, or y equal to this. Okay. So here first, like be sure about the range. Okay. So here y equal to what? Here you can see, na, like this is the case. So that means what? So that means you can write now y2 square is less than or equal to x2. Okay. So also you may also know that this is nothing but less than 1, na, because x can take value or x2 can take value 0 to 1. So always try to remember the support so that you can write the correct support. So this is the case. X2 lie within y2 square to 1. Now our first aim is to find the marginal of x2. And since it is marginal of x2, its range comes out to be y. And the range of y is what? It is clearly mentioned here. The range of y is, sorry, this is the question. The range of y, that means y2. The range of y comes out to be like 0 to root of x2. It comes out to be like 0 to root of x2. It's y2, not y. Okay. And yes, it is now 6 x2 y2 dy2. Again, 6 x2 is taken as common. It's y2 is square by 2. It's 0 to root of x2. Just simple calculation only, nothing else. It's 3x2 into like x2 again. So it comes out to be the marginal of x2 is nothing but 3x2 square. And the range of x2 is what? It comes out to be 0 to 1. Okay, this is simple calculation. Now the next step is to find the marginal of y2. So it's f2 of y2. Marginal of y2 is what? So here it comes out to be x2, and the range of x2 that we have already defined here. The range of x2 is this, no? Using all the condition. The range of x2 is this. So y2 is square to 1. The lower limit is y2 square. The lower limit is y2 square. The upper limit is 1. And yes, 6 x2 y2 dx2. So 6 y2 can be taken outside, and x2 is square by 2. It's y2 is square and 1. So it comes out to be 6 by 2 by 2. We can say by 2, 3y2. That means it's x2. So x2 equals 1. So 1 square comes out to be 1 minus y2 square to the square, because x2 is square and the value of x2 is y2 square. So that means y2 to the power 4. So our the marginal of y2 comes out to be like what? P y2 1 minus y2 to the power. Okay. And yes, you can check and you will find that this is a proper PDF as well. Now we have marginal of x and marginal of, sorry, x2 and marginal of y2. Since f, you can see actually directly f2 of x2 into f2 of y2 is not equal to f2 of x2 y2. So this implies what? It is not independent. So this means what? This means we have 4 condition actually. We have 4 condition here. So that means x1 y2 is independent and x2 y2 is not independent. The option 1 is the correct one. Okay. So is it okay up to this point? Anyone have any doubt? Any query? How we have solved this question? Anyone? No. Okay, then we will solve next question then. Like the next question is based on the covariance. We need to calculate the covariance for the discrete case. So the question will be like, consider x and y be two discrete random variables. Two discrete random variables with joint probability mass function PMF, as we are given the PMF here. Okay, I can write here smaller. Y equal to 1, y equal to 2, y equal to 3, x equal to 1, x equal to 2, x equal to 3. Okay. Okay. Use the different colors. We are given it's 0, it's 1 by 2, it's 1 by 8, 0, 0, 1 by 8, 1 by 8, 0, 1 by 8. Okay, this is the case. Okay, I have written something wrong. Let me correct it. So it's 0, 1 by 2, 1 by 8, 0, 0, 1 by 8, and it's 1 by 8, 0, 1 by 8. Okay, these are given. Now we can calculate the marginal from here if you want. So it's marginal of y equal to y, it's marginal of x equal to x, comes out to be like what? Comes out to be 1 by 8 plus 1 by 2, it's 5 by 8, it's 1 by 8, it's 2 by 8, comes out to be 1. Here it's 1 by 8, it's 1 by 2, it's 3 by 8. Okay, so yes, it is a proper or valid PDF or a PMF. Now the question is to find the covariance between the random variable xy. Find the covariance between xy. Okay. So yes, it's not that much like tough question, just a simple calculation. The whole today's lecture is based on the only calculation and topic concept. The concept already you need to find the covariance of xy between xy. So yes, what is the formula for covariance? Covariance between the random variable xy comes out to be like what? Expectation of xy minus expectation of x, expectation of y. This is the formula. Okay. Now let's first calculate the expectation of x. The expectation of x is what? X comes from 1 to 3, x into probability that x is equal to x comes out to be x is equal to 1. Then the probability that x is equal to 1 is 5 by 8. So 1 into 5 by 8, because this is the case. No? This is 1, this is 2, this is 3. We are considering marginal distribution. Okay. So it's 5 by 8 plus 2 into 2 by 8. Sorry, 1 by 8, not 2 by 8. 1 by 8 plus 3 into 2 by 8 plus 3 into 2 by 8. It comes out to be 5 by 8 plus 2 by 8 plus 6 by 8 comes out to be expected value of x comes out 8, 5, 13 by. Similarly, you can find the expected value of y, which is y from 1 to 3, y into probability that y equal to y. These are just calculation. Okay, y equal to 1 into y, at probability that y equal to 1 comes out to be 1 by 8. 1 by 8, 1 by 2, 3 by 8. Okay, so it's 1 by 8 plus 2 into 1 by 2 plus 3 into 3 by 8. Now it's 1 by 8 plus 1 plus 9 by 8. So it's what? 8, 1 plus 8 plus 9 comes out to be expected value of y is 18 by 8 or 9 by 4. Or yes, 1.25. No? Sorry, it's 2.25 if you can write. But no need to write this. We will use 18 upon 8 only. Okay. Now what? Now the laborious one, that is the expectation of xy, because the formula contains expectation of xy. So expectation of xy is like the first is at x equal to 0, y equal to, and z equal to. So if you people may like take a screenshot or click the picture, x is equal to 1, y equal to 1 at 0, x is equal to 2, y equal to 1, the probability is 0, x equal to 2, y equal to 2 has probability 0, x is equal to 3, y equal to 2 has probability 0. So 4 probabilities are 0. So yes, we can directly solve this. I'm writing. So at x is equal to 0, y equal to 0, it comes out to be, sorry, x is equal to 1 into y equal to 1. The probability at x is equal to 1, y equal to 1 is 0, plus it's x equal to 1, y equal to 2. At x is equal to 1, y equal to 2, the probability is 1 by 2. Similarly, x is equal to 1, y equal to 2, 3, the probability is 1 by 8, plus now it's 1 is okay. So x is equal to 2, y equal to 1, probability is 0, plus x is equal to 2, y equal to 2, probability is 0, plus x is equal to 2, y equal to 3, probability is 1 by 8, plus x is equal to 3, y equal It's not comma. It's y equal to 1 into probability 1 by 8 plus x is equal to 3, y equal to 2, and probability is 0. And the last, x is equal to 3, y equal to 3, probability is 1 by 8. Just simple. The first value is x value, the second value is y value, and the third value is nothing but the probability, the joint probability of x. Okay. So yes, you may solve this. These are nothing. You may solve and you will find the expected value of xy comes out to be 29 upon 8. Now we need to calculate the covariance, which is xy minus expectation of x, expectation of y. This is 29 upon 8. Expectation of x is 13 upon 8 and 18 upon 8. 13 upon 8 into 18 upon 8. So yes, this is again the simple calculation. 29 into 8 minus 13 into 18. Just we need to solve this. And once we will solve this, we will find this is nothing minus 1 upon 32 or minus times of 0.03125. So the covariance is negative. Okay. Sorry. Again, this is only the question is now if you can see or you can observe, you may find the covariance comes out to be negative. Okay. And you know that. And you already know that like the covariance, sorry, the correlation between the random variable xy is nothing but the covariance of xy and divided by sigma x, sigma y. Since sigma x and sigma y are always positive, since sigma is always greater than 0, sigma y is always greater than 0, that means the value of correlation is directly dependent on the covariance sign. So this implies what? The correlation between x and y is negative. Very small quantity or very big quantity, that is another thing. The thing is, it is negative in nature. So this means what? The two random variables are linearly related, but in opposite, in not directly proportional. It's inversely. That means if the one random variable increases, the other is decreases. Okay. So this kind of analysis you can observe with the help of these statistics or these whatever statistical characteristics. Okay. So is it okay up to this point? Any doubt? Okay, then we will solve the next question. Now, this is a simple one. Okay. Let's see how you people solve this question. You need to find the property of the distribution. We are given suppose x and y have suppose x and y have bivariate normal distribution. Bivariate normal distribution. Okay. With parameters. The parameters are like mu x equal to 1, sigma x square equal to 1, mu y equal to 1, sigma y square equal to 9, and rho, the correlation coefficient comes out to be half. Now the question is find probability that x plus y is greater than 0. So can anyone tell me how to proceed? We are given bivariate normal distribution. Okay. And there are 5 parameters in the bivariate normal distribution. We are given all those 5 parameters as well. Okay. Now we need to find the probability that x plus y is greater than 0. Can anyone tell me how to proceed or what are the concept behind this question? Anyone? Okay. Let's see. As we have discussed that in normal distribution case, it follows the marginal. Suppose it's a bivariate normal, then its marginal is also normal, its conditional is also normal. It follows a linearity property. Okay. So yes, we can use some of the properties directly. So how we can use? We can use directly let's set z is x plus y. Simple. So you know that x is a normal random variable, y is a normal random variable. So x plus y, which is a z random variable, again, or let me write it 0 actually, not z, sorry, u, because z is used in another term. Okay, u, that is x plus y. We have transformed the random variable, which is the sum of the two normal random variable. So now what? Since x follows normal, mu x equal to 1, sigma x square is equal to 1, y follows normal, mu y equal to 1, sigma y square is equal to 9. So obviously x plus phi equal to u. This is follows again the normal distribution with mu x plus mu y, which is 2. And sigma x square plus sigma y square comes out to be 10. Okay, let me see first. There is one mistake. Yes. Uh, there is one mistake, not mistake actually. Let me write in the next line so that it is clear. Because there is, we do not have information about the whether the x and y is independent or not. We do not have given anything about this independence about the random variable. So the general formula will be like this is the mean mu x plus sigma x, and the variance will be like sigma x square plus sigma y square plus twice of sigma x sigma y times of rho. Okay. And yes, this value, if you can use directly, you may find. So its sigma x square is given 1, sigma y square is 9, that is 10, 2 into half, that is 1 into sigma x sigma y, 3. So overall, it comes out to be like 30. Okay. So that means what? U follows normal 2 and 30. Simple. The linearity property of normal distribution. Clear? Now, the next question is the next step is not the next question. The next step is to find the x plus y is greater than 0. So the probability that x plus y is greater than 0, it is probability that u is greater than 0 because u is another transform variable which is x plus y. Okay. So yes, since we know that in the previous lecture, the previous class, that the normal distribution, when we are discussing about the normal distribution, then we are not able to directly integrate the normal PDF. So we use first we standardize the normal variate to standard normal variate, and then with the help of the normal table, we calculate the probability. Okay. Okay. So it is what? It is like u minus mu u upon sigma u. Okay. Mu u is equal to 2 and sigma, it's u not sigma u, sigma square u, that is 13. Okay. So from there, greater than 0 minus 2 upon root 30. Up to this point, is it okay? Now, this random variable is standardized, u minus this, and this is called z, is greater than, it's minus 2 upon root 13. Okay, it's minus 2 upon root 13, which can be like minus 2 upon root 13. So you can solve this now. These are very simple. Is minus times of 0 point, it's 5547. Okay, now the next step is to draw the curve. Okay, always draw the curve in case of normal distribution. Suppose this is a kind of curve. Okay, so what? It is z equal to 0. And we need to find the probability that z is greater than minus of 0.5547. So obviously, if you may clearly understand, suppose this point is minus of 0.5547 and the probability is greater than that. So greater than that means what? This side, no? Greater than that means this side. So last time in last class, we have a table which have only 0 to at point z. We have the probability table for 0 to at that point z only. Okay. So this can be like written in this formula. So probability that like minus 5547 to set to 0 plus probability 0 to like z to infinity. Okay. This z is greater than this can be written in this form. Minus 0.5547 to 0. That means this particular section. Okay, sorry. That means this particular section. And then 0 to infinity. So that means we use some other color. Color combination is not good. Okay. So now the property of symmetricity. Now with the property of symmetricity, the z is greater than 0 comes out to be its. Okay. Let me write again one more thing. This is what? This can be written like this. The property of symmetricity, it's 0, it's z, it's 0.5547 plus this value comes out to be 0.5. Okay, these are already we know. Okay, now the thing is, I have written this particular expression into this format because in last class we used the table. For that we need to write these. Okay, if you have different kind of table, you need to understand how to solve how to check the value. So that's why I am telling you that always try to draw the curve so that your concept is clear, which area you need to find out. Now if you are going to see the normal table, you may find its value comes out to be like 0.2123, that is 0.5. So the probability that x plus y comes out to be 0 is equal to 0.7123. So this is the final probability. Is it okay up to this point? Anyone? Okay. So the next question will be like, suppose x and y have a bivariate normal distribution. Suppose x and y have a bivariate normal distribution with parameters we are given like mu x is equal to 0, sigma x square is equal to 1, mu y equal to -1, sigma y square equal to 4, and the rho is equal to -half. Now the question is find a. There is a small a such that ax plus y, the one transform variable, and x plus 2y are independent. We need to find the value of a in such a manner that this, suppose this is u, ax plus y, this is u, and x plus 2y, that is v. These are independent in nature. Okay. Is it okay? The question is clear? Now it's simple. It's like we are given, suppose u equal to ax plus y and v equal to x plus 2y. So obviously, when we need to show that it is independent, then that means its covariance between x and y comes out to be somewhat 0. Okay, comes out to be 0 for the correlation or the covariance, both have same meaning. Okay, not the same meaning, that would like infer the same thing. Okay, the covariance and the correlation infer the same result. The covariance of xy comes out to be 0. Now, sorry. Now, it's like we have one more like a formula. Okay, there's one more formula. Let me write here. It's covariance between ax plus y and x plus by. X plus by. That means we have a and linear combination of the linear combination of the variable x and y. Then we need to find the covariance between those linear combination of the random variable x and y. And this formula says like the covariance ax plus this and this comes out to be a times of covariance of xx. That is nothing but the variance. Okay. Plus a b times covariance of xy. Okay. See what I have done. What I am doing actually. This first case. Okay. Then this second case. So a b covariance of xy. Okay. Now the next is what? It's plus covariance of yx. Covariance of yx. Okay. And the last one is what? Plus b times the covariance of yy. Okay. So this is the formula. So for the same case, when we put our numerical value, the covariance between ax plus y, ax plus 2y, ax plus y, x plus 2y. Okay. So it is what? This comes out to be like a times covariance of xx plus twice of a times covariance of xy plus covariance of yx plus twice of covariance of yy. Simple. We are given the numerical values. Okay. We're already given the numerical values like mu x, sigma x square, mu y, sigma y square, and rho square, sorry, rho, not rho square, rho. So putting the values from there directly, we can find, okay, there is one more thing. We need to find the covariance. And yes, there is one more formula that we have already discussed. The covariance between x, y is what? Rho times sigma x, sigma y. Is it okay? Because rho is equal to covariance upon sigma x, sigma y. So from there, covariance of x, y comes out to be rho times of sigma x, sigma y. So from here, rho that is minus half sigma x. Sigma x is 1 and sigma y is 2. Because sigma y square is 4, that means sigma y is 2 into 1 into 2. So covariance between the random variable x, y comes out to be minus 1. This is the value. And also the covariance of yx comes out to be minus 1 again because it is commutative in nature. It commute. So it's commutative in nature. Okay. So just we need to put the values and its covariance of uv. I have written uv because instead of a and b, sorry, ax plus b and x plus 2b, it comes out to be a into 1 plus 2, a into minus 1 plus minus 1 and plus 2 into 4. After solving, a minus 2a plus 1 minus 1 plus 8 minus 1 plus 8. So it comes out to be minus a plus 7. Okay. Since we need to find that the value for of a such that it is independent. So that means what? So that means covariance of uv equal to 0 equal to 7 minus a. Let me write it 7 minus a. From there only a equal to comes out to be 7. So the value of a is 7, for which the above linear combination of the two random variable x and y is independent in nature. Okay. So this is the case. Any doubt? Any question up to this point? No. Okay, then we may find some more questions. The next question is find correlation coefficient between the random variable x and y when the joint PDF of x and y is given below. Okay, we are given a joint PDF and then we need to find. So find the correlation coefficients between the random variable x and y when the joint probability density function of x and y given as fxy xy equal to 3xy. Then it x lies between 0 to 1 and y lies between 0 to 1. Okay, so this is the case. This is the question, simple question. We are given the CDF, sorry, we are given the joint PDF and we need to find the correlation coefficient. So yes, the first formula is like correlation coefficient, that is rho, is what? It's covariance between x and y, and it's sigma x, sigma y. Okay, so this is the case. We need to find sigma x, and for that we need to find the marginal of x. We need to find sigma y. For that we need to calculate the marginal of y, and we have already given the joint, so we can calculate the covariance from there only. Okay, so let's start. The first is to find the marginal of x. So marginal of x is what? So it's like integral over y ranges from 0 to 1. It's 3xy dy, which is what? 3x is taken as common, y is y square by 2, it's 0 to 1. So it is what? 3x into it's 1 by 2 minus 0. So fx, x comes out to be 3 by 2x when x belongs to 0 to 1. I can write x is 0 is greater than or equal to x is greater than is less than or equal to 1, or we can write this. Okay. In a similar manner, we can calculate, but let me first calculate all the moments for this only. So now the first step is to find the expectation of x, because we need expectation of x for the correlation, sorry, for the covariance term. So it is what? It's integral x from 0 to 1 x into fx dx. Simple. So it comes out to be like what? 0 to 1 x into 3 by 2x dx. So yes, it's 3 by 2 is taken out from the integral. It's x squared. So x squared, the integral of x squared is x cubed by 3, 0 to 1. So the expectation of x is comes out to be 3 by 2 multiplied by 1 by 3. So expectation of x comes out to be 1 by 2. Okay. Now we need to find the variance of x as well. And since variance of x is what? Expectation of x square minus expectation of x whole square. So expectation of x square is what? X from 0 to 1, x square, it's 3 by 2x. Okay. Yeah. So it's 3 by 2. X cube is there in the integration. So x cube comes out to be x to the power 4 upon 4, 0 to 1. It's 3 by 2 multiplied by 1 by 4. So expectation of x square comes out to be 3 by 8. Now, what is variance of x? Just calculation and nothing else. I'm just calculating continuously. Okay. You can understand how we can go step by step. Okay? So variance of x is what? It's expectation of x square minus expectation of x whole square comes out to be it's 3 by 8 minus factor 1 by 2. So it's 1 by 2 square. That's 1 by 4. It's 3 by 8 minus 1 by 4 comes out to be 8, 3 minus 2. So variance of x comes out to be 1 by 8. Okay. In the same manner, in the same way, you can calculate the y, marginal of y. Okay. The marginal of y, which is again the range of x, because we need to find y, which is 0 to 1, fxy, xy, dx. Okay. And it comes out to be like, it comes out to be, okay, it's again comes out 3 by 2 actually. Okay. It comes out to be 3 by 2 y, or y from 0 to 1. Okay. Now the expectation of y, the same value comes out to be 1 by 2. The expectation of y square, it's 3 by 8. The variance of y, okay, let me write it clear. Here we need to write the capital. It comes out to be 1 by 8 again. Okay. So everything is like calculated. Now, the last is expectation of xy, because the covariance term needed. The covariance of xy is expectation of xy minus expectation of x into expectation of y. The expectation of xy, since it is a product moment, so obviously there is x, there is y, it's 0 to 1, it's 0 to 1. Okay, it's xy into 3xy. This xy is the variable xy and 3xy is our medium. Okay, and since here it is y first, so it's dy then dx. Simple. Okay, always remember the integral, the internal integral limit is y, so dy is there. And if internal is x, the external is x here, so x there. Simple. Okay, so now the next step is to solve this. Okay, you have already solved these kind of thing many times. So you can solve and you may find the expectation of xy comes out to be 1 by 3. Now, the next is covariance. Covariance is like, sorry, correlation. And before the correlation, we need to calculate the covariance. Covariance of xy is its expectation of xy minus expectation of x, expectation of y, 1 by 3 minus expectation of y, 1 by 2 into 1 by 2. 1 by 2 into 1 by 2, it's 1 by 3 minus 1 by 4 comes out to be 12, 4 minus 3. So covariance of xy comes out to be 1 by 12. Now rho, the correlation coefficient, which is our motto. The correlation coefficient is what? The covariance between the variable xy, sigma x, sigma y. So the covariance comes out to be this. And the variance is what? 1 by 8. So it's root 1 by 8. Root 1 by 8 comes out to be, it seems like I'm just solving. Okay, there is nothing I can say. The concept is already discussed. Okay, so it's 1 by 12 into 8 comes out to be 2 by 3. So the rho is 2 by 3 or 0.67, which is positive actually. So that means 67% linear association. We can say not 67%, but yes, we can say like 67% kind of linear association between the random variable x and y for the given distribution. Okay. Up to this point, anyone have any doubt? Because I have completed all the questions that I have prepared. Any question? Any doubt? Anyone? Okay, then if not, then I think we can conclude our session here. Okay. Go on the first page. Am I audible now? Is it visible and am I audible now?
Yes, sir. Yes, sir.
Okay, thank you. So if there is no question, let's conclude our session here. Thank you, everyone. You people may leave the meeting. Before that, let me first stop the recording.